Welcome back, everyone, for our last couple panels of the Rising Stars in Data Science workshop. We're going to start with a panel about postdoctoral research in data science. And just as a quick prelude to that, I'd like to reintroduce Julia Lane, who you saw yesterday. She's the executive director of the Center for Data and Computing, and she's going to give a brief overview of our postdoctoral scholars program, which is currently accepting applications. So Julia, take it away.
Thanks, Rob. And thanks, everyone. This is a candid audience, so thanks for bearing with us as we share a little bit about an opportunity at our center. But I think this will actually nicely dovetail with the conversation on the panel and some of the conversations that we've already had about, postdoc versus going into a faculty position, going into industry, et cetera. So I wanted to mention our postdoc program because it's a little bit unique compared to some of the other postdoc programs you might have seen. And it was created really as an opportunity for folks who have a computational background to take a couple, up to 3 years to immerse themselves in a domain field. So, let's say you're more of a computer science researcher and you're really interested in getting more involved or even deeper involved in medical imaging and using computer vision, for example. That's sort of the opportunity that our postdoc program provides. And we do this through joint mentorship. So in addition to having a computational mentor, you will also have a domain mentor as well that you can choose as part of the program. There's a lot of really exciting benefits to that, and I think we can definitely go into that and we can answer questions as well. Obviously, access to great data sets. You've probably heard from some of the faculty members that we met with yesterday about what are the resources here at UChicago, and we can go into that. I also wanted to kind of highlight something about outreach and impact. That is an incredibly important part of the Center for Data and Computing's mission. We don't want to be doing research that is only for, we don't want to be writing papers just for our friends. We really want to make sure that our research has impact. And that also the impact that we have is positive, and we are able to engage with stakeholders in a meaningful, equitable way. And so our center has a lot of connections with both the city of Chicago, with other community members, with industry as well. And this is something that all of our postdocs have have access to, as well as their own connections. So that's something that we really want to facilitate, is building your network, being able to get you to do the type of research you really want to do and help facilitate that. I'll also mention that we have currently 4 postdocs and we'll be recruiting more. And so there's actually a cohort of postdocs, and we have dedicated professional development programming as well. So you're not going to be by yourself in a lab or, in a small group or something like that. There's going to be other folks who are doing the exact same or in the same sort of stage in their career. And that's a great community to have as you are navigating your next steps. So I do think that is a really useful benefit. Just kind of moving on to some of the more particulars of the program. We can go to the next slide. Let's see. I wanted to mention just how the postdoc is structured. So postdoctoral researchers at CDAC can have at least 50% of their time on their own independent research. And then we have some amount of time also around this interdisciplinary research that would be done in collaboration with your mentors. And then also just a little bit of time on professional development. This can be, again, it really depends. It's tailored to the postdoc. It depends on what's interesting to them. Some people are interested in communication work. Some people are interested in learning about how do you seek funding, things like better writing, things like that. But these are all resources that are available. I also want to highlight the potential mentors that are available to postdocs. They're not just from one department, which is also very unique. We have a list of potential mentors on our website, and I just wanted to highlight a couple here in this presentation, but there are more on our website. Also, those are just examples. If you're interested in working with somebody that's not listed, our center can also help facilitate that connection to ensure that you get to work with the person that you're interested in. We also have included example projects that would be of interest. But again, these are just example projects, not something that you have to work on specifically, but just to give you a flavor of the type of research that could be possible. So you heard from Becca yesterday and Mike Franklin as well. So those are two faculty members in computer science, and Becca's also in statistics, but she does a lot of really interesting work around AI and science. I want to mention Senthil, who is a professor at our Booth School of Business, does exceptionally exciting applied AI work on various projects, including healthcare, as well as Chibueze, who is a professor in our department of, in our Pritzker School of Molecular Engineering, and is actually using machine learning and AI to develop new materials for batteries and other applications. So super exciting folks who have a range of backgrounds and are really really excited to help train the next generation and support you as you're in your career path. So all right, that's my shameless plug. But if you have any questions, feel free to ask them now. Also, feel free to reach out to me over chat or Slack or email if you have additional questions. Nick Feemster, our faculty director, from who you heard from this morning, would also be available to ask questions, to answer questions as well. All right. I will pass it over then to the panel. Again, think of your questions and feel free to Slack me or send me a message. And so I'm going to turn it over to Jamie Saxon, who is a postdoc at our center, and he can tell you if anything I said is true or not. So as well as what's it like to be a postdoc.
Hey, thanks, Julia. So hopefully you can hear me. Otherwise, shake your heads. So not that way, this way. Hi, my name is Jamie Saxon. I'm a postdoc with CDAC. My formal training was in particle physics. I came to CDAC through the physics department and the policy school and officially social science. So I did a lot of work with large data on mobility, and then within CDAC on understanding broadband as a specific community resource. I'm really excited about the 4 people who are on the panel, and I wanted to sort of invite them each to just say in 2 or 3 sentences, just their current affiliation, their field, and names. So maybe we can start, call off Qinyun. Can you go?
Sure. Hi, everyone. My name is Qinyun Ling. I'm currently a postdoc working in the Center for Spatial Data Science. My primary research is like the quantitative research methods, including social and spatial analysis, causal inference, hierarchical linear models, things like this. From applied perspective, like my PhD work is mainly in education, and right now I'm in public health. And I have been postdoc for just over a year. It's crazy. It's a crazy year. Yeah.
Thanks, Tarun.
Yeah. Hi, everyone. I'm Tarun Mangla, and I'm also a postdoc at CDAC. So I'm in the same cohort as Jamie. So I joined in September, and I'm formally a researcher in network measurements, or computer networking is my research area. And I've been working, as a postdoc, I've been working in problems related to network measurement data, all kinds of measurement data, including understanding broadband access with Jamie, and also looking at problems at intersection of network data and machine learning. I'll be happy to talk more about it. And in my PhD, I've worked on, again, understanding application level performance using network data. And the kind of applications I'm talking about are like Netflix, YouTube, like how to understand the Netflix streaming experience using network data. So that's the kind of problems I've worked on.
Anna?
Hi, everybody. My name's Anna Woodard. Like Jamie, I also have a PhD in experimental particle physics. And I love physics, but by the time I graduated, my interests had kind of shifted, and I wanted to work on something a little less esoteric. So I got a postdoc here at UChicago in the computer science department. So at the end of March, I'll have been here for 3 years. I started off focusing on distributed and high performance computing. So building tools that try to make high performance computing more accessible and more reproducible. But that was a lot of fun, but it was a bit more engineering than science. And so about a year ago, I started to split my time as a data scientist in a cancer genomics group, also here at University of Chicago, being mentored by Fumio Olapati. And so this has kind of been a homespun version of the cdac postdoc in that I now have both CS mentors and domain expert mentors. And they've been incredibly welcoming and supportive. And so they're kind of letting me explore a few different projects according to my interests. So for example, one of the things that I've done is to build a tool that uses machine learning to try and better identify a certain kind of cancer mutation. And another project that I'm getting off the ground right now is combining genomic and imaging data to try and predict breast cancer risk. So kind of all over the place, but just having a lot of fun exploring different things.
Thanks, Anna. And Stefan.
Hi, my name is Stefan Uddenberg. I am a principal researcher, which is just the booth term for postdoc at the Center for Decision Research. I work with Alex Todorov, who's a recent hire here, or recent poached hire, I should say. I was at Princeton before, working with him as a postdoc for a couple of years. And before that, I did my PhD in cognitive psychology at Yale. And I'm a vision scientist by training. So I study how we see and remember things, especially with regard to faces. So these, for the last little while, couple of years, I've been working on these models of faces. So Alex's lab is famous for having made these generative models of facial impressions, like models of faces that you can make look more trustworthy or more attractive or whatever you could think of. But they are in some ways out of date because they look pretty much like 3D mannequins. They're all bald-headed faces on black backgrounds. So my goal, because I've got lots of questions about how faces work and I keep getting thwarted by the existing face data sets out there, is to sort of cut the Gordian knot with that and make a model of faces that lets me make realistic looking faces that I can manipulate and stuff. So we've got this tool now that lets us manipulate faces and generate faces in all sorts of different interesting ways. In my PhD, I worked on sort of what our mental defaults for faces were. Like when you think of a face, what kind of face comes up? What kind of person emerges in your mind? So I did that using basically like the game of telephone to have people play the game with faces, where you'd see a face, it would go away, and then you have to reproduce that face by morphing through some continuum. And then the face that person chose gets fed to the next person. And we found, for example, that white observers make that face into a white face within 10 faces, even if you start with a super, super black face. So that's the kind of thing that I work on. And yeah.
Thanks, Stefan. So this is, data science, and at least speaking as a practicing data scientist, I'm not sure I have any idea what that is supposed to be at this point yet. And in particular, within the academy, there's a question of where we stand in terms of just technical skills and specific subject matter expertise. And so my first question that I'll just pitch to you and then it goes to anyone is, what makes a good scientist? And are we just, how are we different from just data techs who are extremely computationally capable? Your research is a particularly cool marriage of that. So I was hoping you might start it off.
Yeah, I think you're addressing that at me, or?
Yeah, exactly.
Yeah. Okay. Yeah, I mean, so I think of a scientist as someone that does science, and doing science means answering questions about how the world works. You have, a scientist goes out and explores things. An engineer builds things. And sometimes in order to explore the questions that you might have, you may need to build some tools to get to where you want to go. I think that a lot of people are afraid of building the tools that they need to explore the questions that they have. So we get a lot of streetlight effects going on in science in general. The streetlight effect being that sort of fable of someone who you see like a drunk person searching for their keys and under a street light, and you come along and ask, what are you doing? Why are you looking for your keys there? And did you drop your keys there? And they say, no, well, I didn't drop my keys there. I dropped it all the way in the parking lot, like 10,000 feet away. And you're like, but why are you looking there? And they answer that because the light is better there. And the idea is that I think that we as scientists tend to go to wherever the light is best. So if someone comes up with a cool method, everybody just starts using that method to investigate questions, even if that's not where the interesting answers actually lie. So yeah, I think that I've gone and developed all these different skills that I have. Like it's not just data science skills that I have. Actually, my main skill at this point is probably web development, because I need to collect all this crazy data from people in all sorts of interesting ways. So I think I'm a much better web developer than I'm a data scientist at this point. But I would still consider myself a scientist, because at the end of the day, I want to publish in scientific journals. I want to be a professor. I want to answer questions about science. The tools are a means to an end.
So in that, you sort of suggested, right, that you build the tool that you need, but there's another model here. I've done something like this. Anna's done something like this. Qinyun, to a certain extent, I think Tarun's stayed more within the field, but there's another method of taking tools to another place that doesn't necessarily have as much computational sophistication. So maybe could Qinyun or Anna, can you speak to how that's worked for you and how you've been successful in doing it?
Anna, you go first.
I think that that's worked really well for me. I think that definitely, for better or for worse, I think that kind of cross-pollinating different fields has often been a bit of low-hanging fruit in my experience. It's kind of an easy way to have a lot of value add, because just by way of being from a different field, you can have a lot of new perspectives. And so when it comes to kind of really making that work, this sounds a little bit trite, but I think that it's true. I think that communication is key. I think that you really have to meet people on their level and try to speak, to just communicate very directly how you think your tool is going to help them, and why you think that it's important, and why you think that you're excited about it. Because sometimes it can, people can feel a little bit defensive, like, oh, you're just trying to come in and do my work, and that can be a little bit of emotional IQ, I think, to kind of make sure that you're not offending people with your new ideas. But once you're both on the same page, I think it there's a lot of opportunities. So definitely in computing, luckily for most of the people here, we all have a baseline level of technical expertise and computing expertise. And I think that no matter what field you're in, that is really applicable. So, for me personally, I have a lot of expertise in high performance computing, distributed computing, kind of the big data aspect. And, in my new group, Cancer Genomics, they have a lot of data. So those kind of tools come a lot in handy. So I'll pass it over to Qinyun.
Yeah, so for me, it's more like my basic skills is in econometrics or statistics, like not necessarily in computing, but definitely they are kind of connected. And when like people ask me what field I'm in, I always say I try to be a methodologist, but it's like you also need to think about a theme. I think that's what previously the other panel is talking about, like the science. What the science is like, you still have a theme that you are interested in, and also I always believe that the best methods always stem from your interest in applied field. Like right in my postdoc, the first year of my postdoc, I learned a lot of JavaScript thing, but I don't have any basics in, like I don't have background in computer science. Like JavaScript is brand new for me, but it's like we learned that because we have some work in COVID, we want to do a dashboard for COVID. So like we always have an aim, and then with our basic skills, we are able to learn new skills to answer the question we are interested in. Yeah, that's my response to that.
Thanks. So Tarun, I want to pitch the next sort of question to you, which becomes, right, in one case, it's I have a scientific question, I'm going to figure out whatever it is I need to do it, right? In another one, it's I have some skills and I have a scientific question I'm interested in, by God, I'm going to get there. But so there's a question of what are we all doing in the academy, right? Like we, you know, computer scientists, many of the people in this call, I'm sure, could go and work for Google if they wanted to. So what are the themes and the questions that you're better able to do, having, you know, chosen to become a postdoc here at the university, particularly as a computer scientist?
Yeah, so I'll give my 2 cents based on my experience in the computing domain. So it'll probably differ for different people here on the panel. But I feel like academia is kind of very uniquely placed as opposed to, say, other institutions like the industry or the government. And I think there are two factors that lead to it. One is like there's the kind of objectives as academicians we have, like I think as Stefan also pointed out, like our like one of our objectives is to actually just sort of enhance the knowledge, right? So which has a lot of corollaries, you know, and then I think there's also a huge amount of freedom in the kind of problems that we want to work on. So that places academia quite differently from other institutions. So just to give examples, like, you know, I mean, like just because of this different objective, academia can afford to have a more longer term outlook on problems. So we can think beyond just, you know, like what's gonna make me $1 million, right? Like we can think more fundamentally about a problem. So if you think about a lot of like computation tools in data science or even technologies, like I mean, in machine learning, if you think about like neural networks, deep learning, they all have been initiated by academicians. Of course, industry then sort of took it and implemented it, but the bare bones and the outlook, it came from academia. And I think the other, like coming from this freedom point of view, like there's also a lot like there's also a freedom in deciding what kind of problems that we want to work on. So I'll give you an example from my domain, like networking. Like in networking, a lot of our conferences, the you know, the kind of papers, they mostly come from like industry or in collaboration with industry. Like if it was just for the industry, I think we would not work on problems that I'm working on here. Like, for example, understanding the digital divide in the US, which is actually, if you think about it, it's a data science and a network measurement problem. But if just left to the industry, you know, which is just focused on building faster networks, it's not going to focus on problems like this, right? So then there's also, that's the second point. And I think as academicians, we are also viewed as a little bit non-aligned. So this gives us the opportunity to collaborate with a lot of different groups, right? For my, for my research, I've collaborated with industry, like AT&T, but for other problems, I've also collaborated with communities in Native American reservations, and then also for and recently, like Jamie and I wrote a proposal, and this proposal was in collaboration with communities like in the in Chicago neighborhoods, and then there are technical partners, and then there are like folks from sociology, government, and so on. So I think so we can also like partner with a lot of different groups, which probably like other institutions don't have that flexibility.
Thanks. I think that's a really good answer, and I think it also has highlighted, for me at least, what has been exciting, I think, to be at the University of Chicago broadly, but also cdac in particular. And I want to pitch this to sort of everyone, maybe. Okay, so you've highlighted some of the advantages of academia broadly, Julia gave us, or gave the group a pitch for CDAC. What can we pitch back to Julia and to the university as what is needed for postdocs and for the development of data science as a space institutionally? What support does data science require as this interdisciplinary thing that doesn't immediately have an initial home in the university? Maybe Qinyun, we can start with you.
Sure. So the first thing that came to my mind is probably some like professional development support for both academic and non-academic jobs. For people who are more interested in academic jobs, I think like most of us who position ourselves as data science are probably interdisciplinary, and it would be very helpful to provide some info regarding like what's the publishing norms, what's the different understanding in different disciplines. Like for me, previously I'm in education. Right now it's more in public health, and I noticed there are several different things in like these two disciplines. For example, in public health, like it's more common to have a lot of authors in just one paper, and all of this seem like minor things, but I think like a professional development support like this kind of thing would be helpful. And the other thing, also connected back to my JavaScript experience in my first year, I think it will be helpful if there could be some technical support for some like introductory level skills, including like Python, R, Git, JavaScript, etc. Like, I mean, like we can be both like instructors and students, like kind of help each other learn different software that we are not so familiar with. And I think only those introductory part is necessary and could be extremely helpful, like just help us get started. That could save us some time. And also I noticed that cdac has organized some book clubs, which I think is awesome. Like I feel we are always learning new skills, methods along the way, and it would be great if we can kind of study and discuss with each other, like have a study group together. For example, I'm kind of planning to learn an online course that is focused on causal inference in machine learning. I think it would be helpful if like a few of us are all interested in this, and we can have a study group to kind of motivate each other together, things like this.
Thanks. Yeah, I think just to make a plug for my old center, your current center, in spatial data science, I think they did an extraordinary job of supporting people throughout the university in training, right? Somebody would say, oh, I need to know how to do this. I need to know how to do raster imagery. And no, that there wasn't a course that was explicitly taught on this. Right. And so I have a bunch of questions that I wish I had gotten to, but I want to end on this one. And I also, to the extent possible, want to toss this to the crowd. Right, you mentioned I'm good at something. I'm really good at measurement, but I need to pick up in one case more R, another case more Python, another case raster, another sort of case causal inference. And so as we're considering training the next generation of data scientists, or as professors, just considering training the next generation of educated citizens. And so those are sort of separate parts of that question. What are the statistical and computational either facts or methods that you really feel that we're missing in either a general education or a technical education? And maybe Stefan, we can come back to you first, just sort of those two sides. What statistical pieces should we have generally, and then for the next generation of person who wants to be Stefan, what should we have taught them formally?
That's a great question. In terms of statistical education, I'm actually gonna push back on that a little bit, in the sense that I feel like something that's really would be quite useful for people that isn't done enough, isn't quite statistical, but is related to it or leverages our visual system. So the idea is to just visualize the data. people tend to work at a very far remove from their data and then come up with fancy models that do all kinds of things. But then, and these models end up breaking down because they were based on sort of like statistical seafoam in a sense, as opposed to any kind of real foundation. So I think like actually just having people work a little bit closer to their data to visualize things, you know, view things in violin plots and bee swarm plots, in scatter plots, all kinds of things. And I say those as opposed to histograms because people have a really hard time understanding histograms, and they just don't work well with our visual systems. You know, people think all sorts of weird things about histograms, you know, so that's one thing is to just sort of look at your data more, is something that I would emphasize in education. In terms of what people would need to be the next me, if I think about what I would have wanted at the start, you know, people come to this particular field from all kinds of different areas. I came to it from psychology as an academic psychologist, not the type that helps anyone, but the type that tries to understand basic mechanisms of how we see and think about things. And I wrote a lot of code. I wrote a lot of code in my undergrad years and my grad student years, and all of it was bad. All of it was bad in retrospect. And the reason is that it was academic code. It's the sort of thing where you don't get formal training in this. You just go along with whatever works, and you end up with stuff that does not follow software engineering principles or any kind of real reproducible principles. So your work isn't even reproducible. So I feel like some real basics of computation stuff would be good, like in the sense of like the real fundamentals, like how to use version control, how to organize a small to medium-sized project at the very least, how to organize a file system, how to navigate your computer really fast. So now I'm a power user and all these things, but that's because I had to take time going and just like looking up on YouTube how to do this and take time out of my day for like months and months and months to get that done. I did that late in grad school. But had I done that early in grad school, I would have been way more productive. So that's what I would emphasize. I think that's a gap. I see a lot of people that are just bad at the fundamentals, and they're like fantastic scientists, but because you need to be able to build things, at least in my science, it's rough.
Anna, Qinyun, and Tarun, do you want to take a swipe at that also? I'd be curious for your impressions.
Yeah, I was going to have a like slightly different take because so I'm coming from computing background, and I feel like as a computer scientist, I'm very good at sort of crunching the data. Like, give me any amounts of data, any kind of data, I can write scripts to work on it. But like what I didn't have for sort of formal training on was like a course on statistics, like like building hypothesis, testing the hypothesis. And like maybe it's changed, like I got my undergrad like 6 years ago, so maybe it's changed over time, but I didn't have any statistics course. And I feel like as even computer scientists, like we work with some or the other form of data, so that's a useful training to have for sure. And I +1 on the data visualization thing. Yeah, I think that's a big thing now, how to represent data.
Anna?
I mean, I think those are really great answers. And I mean, in my view, particular, like, oh, it's important to know this distribution and that distribution. We're all well-educated, we're all smart, we can all Google things. In my view, it's really the processes that are the most important. And so that's why I really love Stefan's answer that, especially when it comes to, not just software engineering, but making, reproducibility is an incredibly difficult problem that a lot of smart people are working on, and it's not solved yet. But even reproducibility of your own work is really a critical thing that just amplifies your own productivity like a huge amount, because a lot of work is iterative, and a lot of times you'll do a certain piece in one project and that goes into another project.
I think that progress in research is not, you know, a train, right? It's like branches on a tree, and it's always going off in different directions. And so the efficiency with which you can go back and reuse a piece that you've made in the past can really, really amplify your effectiveness. And I think that the key to being able to do that well is, like Stefan said, you know, really getting comfortable in your computing environment, especially version control. I also think that, you know, I'm really passionate about open science and reproducibility, but I think, you know, not just reproducibility of your own work, but to the extent that you can easily share your work and allow other people that otherwise have, you know, throwing things up in a notebook that you can kind of share with collaborators. Whereas, you know, the alternative might be to just, you know, share a short slideshow with them. But if you can put it on a notebook and let them just go and see exactly what you've done, often you can get a lot more feedback that way. So I think that tools that contribute to processes are the most important, and especially computing ones.
Qinyun, do you want to take one last hit before we go to the audience questions? So please, to the audience, if you have questions for the University of Chicago or this program or generally, or suggestions about what we should be training, I would love to open that more broadly.
Yeah, I think all those are really great points. Like I always copy paste my R code from one project to another, and then basically do similar things. And also I spend a lot of time learning GitHub, like in the version control. That's all really important things. And just one small thing I would like to add is, I think it would be helpful for us to really learn those basic stat concepts really well, like p-values. Like a lot of people really misunderstand even p-values. I think in this time, in the big data science time, it's pretty important to like at least well understand this basic stat concepts. It's definitely not necessary to remember those distributions, right? Like I forgot all of them once I finished the exams. But like all those p-values, those standard errors, those kind of things, I think those are important things to know. Yeah.
I super appreciate that answer. That was my answer. So I'm glad that somebody actually said p-values and just distributions, broadly speaking, having taught statistics. So I'm gonna do just one last one before we go over. Everyone here, you know, is excited to be a scientist, is basically dedicating their life to doing this, which is great. But you are also going to live for another, 60 years, and you don't have a terrible life. Hopefully, well, I speak for myself only, I suppose. And so, how do you balance work and life as a postdoc, and how has that changed since you were a student?
I would like to start off if you guys don't mind. So when I was a student, sometimes, for some periods I would work 40, 50 hours a week, but there were, very long periods where I worked a lot more, sometimes 70, 75 hours a week, sometimes it just, especially, for a paper deadline or something, and you just can really get in a situation where you're often working really, really long hours. And that has all changed since I became a postdoc. I now work, probably 40 hours a week, plus a few hours here and there on nights and weekends, but I really strive to keep that to a minimum. So I've been here about 3 years, and I had my first kid, Sebastian, during my first year of my postdoc. And then I had Penelope during here. So there wasn't actually even an official leave policy for postdocs when I had Sebastian, but thanks to a lot of support from my mentors and a lot of work and support by administrators, and also, just some directness about my expectations on my part, I was able to take 3 months off paid. And then I took an additional 3 months off at halftime. And I'm supported on an NSF grant. So I applied for and received an NSF work-life balance supplement, which meant that my leave didn't hit my PI's grant. That's very easy to apply for, so I highly recommend that people apply for it if it fits their situation. And then for Penelope, I took 3 months off again. By that time, there was an official leave policy for postdocs, which is great. I think that UChicago is really putting their money where their mouth is in terms of diversity and really supporting people that need to take leave. And like you said, Jamie, typically us academics, you know, we aren't in it for the money. We're here because we really care about our work and we think it's important. And that's a great thing. I think it's a big advantage of working in academia. But the other side of the coin is that, you know, there's often pressure, often intrinsic pressure that we put on ourselves to not only be a hard worker, but to be viewed as a hard worker and to minimize or make excuses for time that you take off. And in my view, this leads to suboptimal outcomes because, you know, both personally and for science in general, because it leads to a lot of brain drain and it makes science less inclusive. So when I take time off, I try to be really visible and open about it because I feel like I'm setting a good example for, you know, for students, for example, in our group. And unfortunately, time is a conserved quantity. So when you work less, you need to work more efficiently to get the same amount done. But I think that that's fine because there's a lot of low-hanging fruit in terms of efficiency. I think that it just means that you need to keep kind of your big picture goals in mind. And when tasks come up, you need to ask yourself, you know, is this really in line with my big picture goals? And that doesn't always mean that your work is a linear march towards some endpoint. You know, it's fine to take detours, but it does mean that you sometimes have to learn to say no. So that has been kind of a big revelation of my postdoc experience.
Yeah, I would open the question to anybody. I think it's super awesome that you identified and used and have been so successful in CS and medicine using the resources. I will say, like, I also had a kid, and the university had a policy. I was formerly an instructor in Harris, and I used that policy to make sure that during the time when my wife went back to work, you know, we didn't fall apart. And I didn't fall apart either, right? So I think it's also, and I guess I would say this for guys also, like, you do have to like talk with your spouse, right? Because a lot of people have academic spouses, and okay, so I would put that out there. But I wonder if other people have thoughts on work life, particularly since becoming a postdoc, and how that's changed.
Probably I'm lucky. My husband I work as a like engineer, so not in academics, and I don't have any kids, but we have 1 dog, 1 cat. So like my trick is that I always take at least 1 day off during the week. So on Saturday, I try my best not to work. Well, if there is a deadline on Sunday, then there is no way to avoid work. But in most scenarios, I try to take at least 1 day off during the week. I learned that from my PhD advisor, and I found that pretty useful for me to kind of keep myself as sane as possible.
Tarun and Stefan, how do you guys work weekends? How have you have things changed for you since becoming a postdoc, or how has that evolved over the course of your entire academic trajectory?
So I think I can't beat what Anna and Qinyun said, but as a recent postdoc, I'm still figuring out, like, I mean, it's been only 4 months, but like one of the things that I realize is as a PhD student, you typically work on problems by yourself, whereas as postdoc, you collaborate a lot. So I think like you can't do things in a bursty mode. Like you have to be consistent, otherwise you'll just go crazy. So which means that so like, I mean, as a PhD student, I would like, there'll be days I am not working, like I'm not doing any sort of concrete work, but then there'll be days I'm like stretching myself out. But that is one thing as a postdoc, I think it's not productive at all, because all of your projects are in collaboration with others, and You can't like that. There's not a luxury. I mean, of course, like I'm just talking about the work, not the family aspect of it. So I think like being consistent is quite important. So and also sort of prioritizing, like the work is endless. There'll be it's never gonna end. So I think just making sure like what is important to you, like having that clarity is quite important. So yeah.
I agree with that entirely. Consistency is way more important as a postdoc, but it's also something that you just develop. I think you just develop the discipline as time goes on. You know, a lot of it when you're working in a bursty mode, at least my experience as a grad student is sort of resulting from anxiety over the work, where it's like, oh no, I need to make an experiment that's gonna like be so hard for me to do. I'm such a noob at JavaScript, everything is terrible. So I'm just gonna put this off, and then I'm gonna spend 40 hours on a weekend, Saturday through Sunday, to get it done so that my advisor has something to look at on the Monday. That was my mode in grad school. Now I'm at the point where I could make an experiment in an hour, but at that time, not so much. So you just, as you gain mastery, it becomes easier to have work-life balance in a sense. Now I would come from the other perspective of just, my advisor always says, beware having an overly balanced life at this stage. And the reason is that, you know, at least what I'm trying to do, I'm trying to be a professor at a fancy school somewhere. That is a very hard thing to do. I don't know to what degree I can really have a super balanced life where I get to smell the roses and everything until I achieve that particular goal, you know? Like at that point, I can be a little bit more balanced. But it's also the case that COVID has completely destroyed any semblance of work-life balance I might have had, because now there is no life outside of work. Like I'm sitting right now in front of my computer that is for work and is also for play and also for other things. And it's just really, it's changed the way that I engage with the world a little bit as a result. I look forward to post-COVID times when I can go back to having more exploratory mode of the world and to actually see what Chicago has to offer. I've been here since July, but I've never seen the inside of the building at Booth, for example. You know, it's a very weird time. So it's also a strange time to be asking about this kind of work-life balance issue, at least for me. I don't know about for other people.
Yeah, cool. So why don't we turn towards the chat and Teng's question, and your experience with this joint mentorship. And I think I might send this one to Anna first. She's not official cdac, but she has spun this so well. Being split between CS and medicine, how have you worked with those two different advisors over your time as a postdoc?
That's a great question. Thanks for the question. I think it's evolved pretty organically and worked out really well. I think that people tend to just play to their strengths and their kind of comparative advantage. So, you know, I think my domain expert mentor is really kind of driving what, you know, kind of helping me refine the right questions to ask. And then my CS mentors are really helping me think about what are the right tools for the job, what's the right implementation, what's the right approach to this. So, you know, one tends to be a little bit more, you know, kind of pie in the sky. This is what I want to do. Can we do it somehow? And then the CS mentors kind of help me think through how it's actually going to work out in practice. So, you know, I found it to just evolve very organically. I haven't really, it feels like, put much effort into tuning the situation. It just kind of seems to work out pretty well.
Qinyun, you also crossed somewhat. I mean, you were doing social graphs, and now it's more spatial graphs. How has that been? You're not joint mentored, but you've changed fields somewhat.
Yes, I've been changed field, but I'm kind of still collaborating with my previous like PhD advisor and other professor I work with during PhD. I think it's pretty, yeah, I think Anna used the word organic. I like that word. I think it really depends on the supervisors, and I'm lucky to have really good supervisors, and they give me the flexibility to arrange my time and then like make some priorities sometimes. Yeah, I think it works smoothly. Yeah.
So Julia had a question that I think sort of relates to this one, which is what are we doing in COVID? And I want to see if I can just expand that just a little bit. At least Tarun and Stefan arrived at the university in the midst of COVID. I switched centers in that time. And so there's a question of how do you make connections? Who do you lean on when we're all sort of separated out? But also, how do you develop new mentoring relationships when you can't have coffee and just kvetch, you know, I'll send that to anybody who will take.
I guess I could just say, you know, I have taken on, I'm rich in mentors. I have taken on kind of another side mentor in this time. And I mean, I think that for me, the key has just been, you know, it's a little less organic. You have to like actually schedule meetings. And great. I mean, no matter what, if you're Slack as you know, a stand-in for, you know, chit chat, work, build a relationship with that you're talking with. And so of course that's much easier to do in life, but I think that even virtually you can do it, but it just requires actually
Anna is freezing a little bit for me.
Sorry, I got frozen. We can just move on. I think that the main idea was just it requires scheduling one-on-one time with people and just putting in the time to like actually have video conversations, not necessarily in a typical meeting environment with a lot of people, but just one-on-one with one person, I find can really get the ball rolling. And another like minor technique that I think is important is smaller meetings are more productive. So I think that to the extent you can make your meetings smaller, it works a little bit better.
Yeah, I think that's
all right.
That's wise, and making sure that you have those meetings, but explicitly scheduling them can be tricky. So Xingxing, we have an impolitic question of what do we like least about being a postdoc. I will at least pair this with what has surprised you pleasantly with being a postdoc. But what don't you like about your job, Stefan? This can go to you first, or
Sure, I don't mind. I'm gonna say there are lots of things, you know, that I love about being a postdoc. I love the autonomy. I love the feeling of mastery that comes from being able to learn new things and gain new skills. I love my advisors. I love my colleagues. It's great. I do really, really like being a postdoc, way more than I liked being a grad student. What don't I like about being a postdoc? I don't like the feeling of being in a holding pattern. Right now, because of the nature of the academic job market, it's basically like being in a holding pattern, circling above, like if you're in a plane and you're circling above an airport, waiting to land. You're waiting for like a runway spot to open for you, basically. COVID exacerbates the situation, for example, where there would normally be like 50 jobs in a year. There were 12 this year, and all of them were at places that, you know, either are just way too competitive or that you would never heard of. So that's one thing I don't like about it. I don't like the sense of uncertainty of the future and being in a holding pattern. Now, at any time, I can press the eject button and go off and get a Google-licious job or something. But I would like to be a professor to the extent humanly possible for various reasons. So yeah, that's what I don't like about it. Everything else is great.
Yeah, I super feel you on the itinerancy. Like you never know exactly where you're going to be in 2 years, and at some point it's like I want to paint my bedroom wall a different color.
I would like that. I would like to be able to settle down in Chicago. I think the city is great, despite having moved here during COVID and not having gotten to like really experience everything. It seems super livable, it's affordable.
Yeah. But yeah, any other other things that you don't like? I think I can add one that I think is true, is that postdocs can't be PIs, generally speaking, on funded research, and that to me is a little bit annoying. One of the things that I asked very specifically for in professional development, that Julia noted at the beginning, is writing grants. And Julia and Nick have gone out of their way to, you know, create opportunities that I hadn't done as much of since I was a grad student, and give feedback and work on it. And Tarun has been working on another one that we just put in. And so I really wanted to do that, but ultimately you have to be on somebody else's grant. And I understand, but it's like, I have things that I want to apply for, and you need somebody to, you know, undersign you.
Yeah. There are a couple, I mean, I guess it also depends on the field. Like there are some opportunities that the NIH has, when you're like an upper level postdoc, 3rd or 4th year, that you can start to apply for. But even so, NIH money comes with various strings. So.
Qinyun or Tarun?
I was just going to echo what
do or don't like.
I was just going to echo what Stefan said. Like, I think the fact that it's a temporary position and also a little bit shorter term than, say, a grad student life, it can sometimes become a little outcome driven. Like you want to get the first paper really quickly, and that is a little bit of pressure, I mean, which is not there as a grad student. So I guess that's the part which can be a little, yeah. But I guess that's gonna be there as a tenure track professor as well. So I think there's no end to that. But yeah, that's a part sometimes I don't like. Yeah.
So we have, I think, time for just a couple more questions. And so I'm gonna go to Shen's, which is, when applying for postdoc positions, what should you value most if you want to go on to academia or if you want to go on to industry? I don't think any of us have been in industry permanently yet, so I'm not sure exactly how to answer that question, but maybe you guys have thoughts on friends of yours who have done that.
I guess I could start just having observed lots of people go into industry from various positions, be it grad school or postdoc or whatever. I think at the time, basically, if you do a postdoc like this, or if you come from a school like this or anything like that, when you're ready, you will just start to take the measures necessary to go into industry. It might take up to 6 months or so to get your feet wet with all the various tools you might need, or you might do, for example, one of those really good boot camps that are free, like the Insight Data Science Project, Data Science Fellowship. I know a lot of people that did that and then went on to become data scientists. But everyone that I've ever known that has tried to do it from the schools that I've been at, and again, I'm from a very small subset of schools, but everyone I've ever known has had no problems getting through with industry. Way more people have had problems getting through with academia. That is just hard. That is difficult. But everyone who has ever tried and stayed long enough, it feels like it's really a war of attrition with academia in some respects. You either get up, at some point you will bubble over. It's like being in a popcorn kettle or something. If you're just one of the seeds of popcorn and they all pop at different rates. But if you stay in the kettle long enough, you will eventually pop and flower into some kind of professor, is what I am told, and what I've seen so far.
I just want to add one small thing. So for international students like me, so one thing to pay attention to is a visa issue. I know UChicago does not support the STEM extension of visa. So I can only use my OPT for the first year of my postdoc. Then from the second year, I need to transfer to either J1 or H1B. And the H1B used by university is different from H1B used in industry. And I don't know how difficult or how complex if you want to turn into an industry job when you hold an H1B visa type from a university. So that's one thing to pay attention to.
Yeah, I would second that as well. That'd be
Yeah, no, thank you for flagging that. I think we are at time, but this has been a great discussion. Most of the answers are not ones that are good, so that's always much more fun to have answers that are not my own. And I'll look forward to seeing you guys in journal clubs coming up very soon. So thanks to you and to the audience for the questions.
Thank you.